The last part of our general algebraic review is on different types of functions, families of functions, and also a little bit on absolute value functions. So functions in graphs and math can take many shapes and sizes. The most basic functions are here on this chart. Okay, already talked about these two, your constant and linear functions. This is a horizontal line, so that's just where your slope is 0. Here's just a regular linear function. We have absolute value, which we'll talk about in this section. Quadratics will be in, which will be in chapter 3. Square root function, cubic function, cube root. You have your reciprocal function. You have your rational function, and your exponential and logarithmic function. You also have the greatest integer function, or the step function. Here, where it says trigonometric functions, we don't necessarily need to know those right now, so we'll just nix them for the time being. Okay, but in all, when you have these types of functions, they're commonly known as parent functions. And any and all functions that you can think of in mathematics are different variations of parent functions. So any change in the position, size, or shape of it, and whether it's algebraically or whether it's graphically, that is called a transformation. Okay. There are 3 main types of transformations that are covered in this section. There's translation, there's reflection, and there is the third one is dilation. And we'll cover all 3 in this section here. So the first one that we're going to talk about is translations. Translations are probably the easiest ones to remember. A translation is a transformation that moves each point in a figure the same distance in the same direction. A translation is also called a slide or a shift. And we can move translations one of 2 ways, either horizontally or vertically. When you're looking for vertical shifts, all right, so let's say I have an original function. Let's say anytime that we look at just f of x, that is our parent function. All right, so the way that we conduct a vertical shift, or anytime that we do any type of transformation, we get a new function, which we'll call h of x. For parent functions, when we apply shifts to them vertically, that means we're changing all the y values of that function. And because we're changing all of the y values here, that means we're changing the value of f of x. So if I'm taking a function and I'm adding or subtracting to that, that is a vertical shift. So the plus c tells you you're going up, minus c tells you that you're going down. When you're doing a horizontal shift, what that means is that you're changing the x values, not the y values. So the horizontal shift, the plus or the minus c, whichever one it is, it only applies to the x value itself, not the entire function. If I'm going to the right, I'm going to subtract that many units. If I'm going to the left, I'm going to also subtract. I'm going to add that many units. And here's why. Let's say I have this function right here. That's my parent function. I'll go ahead and make this a dotted line so you can see a little bit better. All right, so there's my parent function. Let's say that I shift this. Oops, accidentally deleted it. Let's say I want to shift this to the right. If I'm shifting this to the right, say 3 units. 1, 2, 3. And then there's my new function. The reason why I'm subtracting is I'm taking away, I'm trying to calculate how much the distance is between my starting point and my finish point. All right, that's why this would be like f of x minus 3 instead of f of x plus 3. Because f of x minus 3 tells me that if I subtract 3 from my starting position, then I'll end back to where I originally were. And because of this, it can get really confusing Because with vertical shifts, it's pretty straightforward. This tells me that you're going up. This tells me that you're going down. But you can't give into the temptation that just because I'm going to the right, even though a number line going to the right is positive and going to the right is negative, you have to think opposite here. So if you're going to the right, you're going to subtract. If you're going to the left, you're going to add. Okay? So I'll give you an example, and I'll use an online graphing calculator for this. Let's see, desmos.com/calculator. All right, let's say that let's say I'm going to take the function the square root of x. Let's say I want to conduct a vertical shift 2 units up. So that would be square root of x plus 2. I'm adding 2 to the entire function. But now let's also say that I also want to conduct a horizontal shift 2 units to the left. That's x plus 2. And the plus 2 is on the inside of that function, the inside of that grouping, whether it's a parentheses, whether it's absolute value, or whether it's a square root. Horizontal shift takes place inside the function. Vertical shifts take place outside the function. And I'm also going to do one more where I'm going to combine the two. I'm going to take 2 units to the left and 2 units up. Okay? All right, so let's type in this first function. Square root of x. Take this off. And here we go. There's my original function. Okay? I'm going to change this up. I'm going to change it up so that it's a dotted line, because I always want my parent function to be a dotted line here. Now I'm going to go ahead and add another line here. Oops, sorry. Square root of x. Change that to a dotted line. There we go. Okay. Now I'm going to conduct a vertical shift 2 units up. So that means I'm going to take my function and I'm going to add 2 to the outside of it. And there you go. There's my vertical shift 2 units up. All right. Now I'm going to make a third function where instead of going 2 units up, I'm going to go 2 units to the left. Square root of x. And inside, I'm going to put plus 2. And now, instead of moving 2 units up, my function got moved 2 units to the left. And now let's do one more where I combine the vertical and horizontal translation in the same one. Square root of x plus 2, and then plus 2 on the outside. And there we go. So again, my starting point here, go 2 units to the left, and then 2 units up. There's my new parent function. Okay. All right. So those are our horizontal and vertical translations. Okay. Next up, we'll cover is reflections. Reflections can take place across pretty much. You can reflect something across any line, but on a normal basis, we want to reflect something over an x or a y axis. Okay. So a reflection is a transformation that flips a figure across a line called either the x-axis or the y-axis. Now again, we can technically reflect over any line, horizontal and or vertical, but generally we're going to focus on the x and y axis. Okay. So to do reflections, instead of adding or subtracting, we're just going to be adding a negative sign. If I'm reflecting in the x-axis, then if I'm reflecting something across the x-axis, let's go to our coordinate plane here. We're going to use the square root of x again for this example. If I'm going to take this shape, zoom out a little bit. If If I take this shape and flip it over the x-axis, that means the y values change from positive to negative. So the negative sign is being applied to the outside of the function, so only to the y values of that function. So let's reflect this function across the y-axis. And there we go. Flipped across the y-axis. Now, when it comes to the x-axis, if I take this shape and flip it over the x-axis, now the x values change from positive to negative. I'm sorry, reflected over the y-axis. I'm sorry. If I'm going to flip this over the y-axis, now the x values change from positive to negative. So the negative sign is only going to be applied to the inside of the function, where just where the x is. Okay? So instead of putting the negative sign on the outside, let's put it on the inside. Now, this function is flipped over the x and y, over the y-axis. Now, question. Can I reflect certain functions off of both axes? I absolutely can. Here's an example. Negative, square root of negative x. This is an example of a function that's been flipped across the x and the y-axis. All right, so let's show an example. I'm going to put a negative sign on the inside and the outside. So now this function's been flipped over the y-axis and then flipped over the x-axis. So yes, I can do more than one reflection at the same time. Now, what about something like x squared? Let's say I take x squared here. All right? That's my new parent function. So let's say I want to reflect this over the y-axis. So I'm going to do negative x squared. Sorry, the x-axis. So this function can be flipped over the x-axis. It can be reflected over the x-axis. But let's try doing a y-axis reflection. Now look what happens. It's the exact same function, because if I try to flip this across the y-axis, it's the same. It's the same function. That tells me that this function has some form of symmetry over the y-axis. So x squared and negative x in parentheses squared have the same graph. Another question: Can I perform reflections? Can I perform reflections and translations at the same time? Yes, I can. All right. Let's use the absolute value of x as our parent function. All right, there's my parent function. Let's say I want to do the following. For this function, here's what I want to do. I want to do no, not this one. I want to shift this function 2 units to the right. Then I want to make an x-axis reflection. And then I want to do a vertical shift 1 unit down. Now, first off, how do I write this? How do I write this out? Well, here's what I'm going to do. First off, I'm going to do the ones that affect the x values first, and then move out to the y values. So, first thing I'm going to do, shift 2 units to the right. That means there's a -2 on the inside of this square root. Of this absolute value. So again, if you're going to the right, you subtract. If you're going to the left, you add. And do it inside the grouping symbol, whether it's absolute value, square root, or parentheses. Okay. Then I want to make an x-axis reflection. So if I reflect this over the x-axis, I'm making all the y values negative. So that means I'm going to apply a negative sign to the outside here to flip those y values. And then I'm going to shift 1 unit down. So that's down, it's minus 1. So how do I graph that? If I'm graphing it on paper, what I'm going to do is I'm going to take my center point, my start point, and I'm going to go 2 units to the right, 1, 2. I'm going to flip this graph over the y-axis, so now instead of x-axis, so now instead of opening up, it's going to open down. And I'm going to shift that center point 1 unit down, about right here. And then from there, I'm just going to roughly draw this as best as I can. All right, let's see what happens here. Negative absolute value of x minus 2 minus 1. And there you go. Shifts and reflections in the same graph. Okay, moving on. So, anytime that we apply translations and reflections, they're called rigid transformations. All right? And when you think of the word rigid, you think of still, not being able to be bent or twisted. So the initial shape of the graph doesn't change for a shift or a flexion, just the position of it. The last type of transformation that we're going to learn about is called a dilation. And dilations are what's called non-rigid transformations. In other words, the shape of the original function does change. Okay? So, next definition. A dilation is a transformation that either stretches or compresses a figure away from or towards, respectively, an axis. So the vertical stretch and compression stretches or compresses it away from or towards the y-axis, and then similarly for the x-axis, also with horizontal compressions or stretches. So again, just like shifts, vertical and horizontal shifts affect the x and the y values in their own way. Vertical stretch is applied to just the y values. The y values are being stretched or the y values are being compressed. For the x values, you get a horizontal compression if the x value for the x values, if you're multiplying all your x values by that variable c, okay? And same thing for horizontal stretches. Horizontal stretch takes place when your c is between 0 and 1, okay? So right now what I want to show you guys some examples of stretches and compressions, okay? So let's go back to our graph here. We're going to use the absolute value again as our parent. So we're going to do a vertical stretch and a vertical compression here. So we're going to take this function, absolute value of x, and we're going to stretch it by a factor of 2. Then we're going to compress it by a factor of 2. Or, I'm sorry, compress it by a factor of 1/2. Okay? So, let's go ahead and see what that does. And remember, this takes place on the outside of the function. So 2 times the absolute value of x. See how you can think of it as the shape of it being stretched like a rubber band. As a rubber band stretches, it gets thinner and thinner. So we're stretching it away from the x-axis here, right? So here it's going to be stretched vertically. Now let's see what happens when I do 1/2 times the absolute value of x. Now I feel like I'm taking that shape, and I'm going to erase this here, and now I'm smushing it. I'm smushing it towards the x-axis. I'm smushing it vertically, okay? But now watch what happens when I do the same thing, but instead I'm going to horizontally compress it and horizontally expand it. So what I'm going to do is I'm going to take those 2's and the 2 and the 1/2, and I'm going to put it on the inside this time. Okay? So watch what happens when I take the absolute value of 2x. on the inside. So notice how it's the exact same as and remember that's a horizontal compression because the C is greater than 1. So as I'm stretching it vertically, I'm also compressing it horizontally. Okay? So vertical stretches are similar to horizontal compressions. On the flip side, as I compress something vertically, it stretches out horizontally. So vertical compressions are the same as horizontal expansions. Okay, so dilations are pretty tricky because you never know how something can be a vertical stretch or a horizontal compression or vice versa. I don't plan on covering much on dilations unless absolutely necessary. For the most part, I do want to focus more on reflections and translations, especially since in this section we're going to be doing that a lot with absolute value functions. So keep an eye on your absolute value functions, and let's go ahead and start transforming functions.